Okay guys, we're getting ready to finish out our new lead screw. We've got to get our Woodruff key milled in this, and we've also have our straight key milled on the end for the bearing retainer lock there. So what we have is a 505 cutter, okay? 5/32 on your width, 5/8 diameter. This is going to be the depth at which you cut that. And then the key height, which is the height of the key sticking out of the shaft once it's bumped down into the key seat. So a 505 cutter size. How do we know what a 505 cutter size is? Well, let me show you. Let me move our lead screw over here out of the way. We've got a 505 cutter and a number 6 cutter, which are exactly the same thing. And I'm going to show you what I mean by that. So if you take your Machinery's Handbook, I have the 20th edition here. Pages may be different on some of the other older editions. I haven't checked. If you go to page 1626, this chart right here gives you all of your specs for Woodruff key seat cutters. The cutter number, the manufacturer's number, in all sizes that are standard in both shank type, which is what we have. This is a shank type. And then you have an arbor type there as well that goes on an actual arbor. This gives you all your dimensions, A and B, on your width and diameter of the cutter. In addition to that, you can go to this other page in the Machinery's Handbook. All right, this page right here, which is page 1000. This gives you all of your information on key seats and a shaft. All right, and so whenever I go down here to a 505 key size, 5/32 by 5/8, it's telling me that the depth is going to be 166 thousandths, or let's just round it up, 167 thousandths. All right, and then you'd have a tolerance of plus 5 thousandths minus 0. All right, so this is where we get our information for all that right here. So if you're looking to educate yourself a little bit more, be a little more aware of Woodruff cutters, the sizes, the size of the cutters, and the dimensions for both the cutters, the key seats, even internal keys, go to your Machinery's Handbook and it's going to give you all the specifications that you want to know on that, all right? So just trying to help you guys out. This has got lots of good information in there. I went through our old stash of Woodruff cutters there. We've got a lot of different sizes, and luckily we actually had 2 of the cutters that we need to get this job done. We're going to be using this guy right here, which is labeled a number 6 cutter, and this one right here is labeled a number 505 cutter. You can see it right there. Both the same size, and we're going to go ahead and use the Morse number 6 cutter. So we're going to go down to the do-all mill and get our shaft set up and mill these keys. For our work holding, I'm going to use a 5C collet block. This is a 3/4 inch 5C collet. And it's going to hold this shaft just nicely while we cut our key. So I'm going to go ahead and stick it in there. I'm going to go up kind of close to the area that we're going to mill right there. Let me grab the cutter, and we'll be coming down here about like this. So I think that's going to give us enough room to cut our key, and then we'll come down here with the same Woodruff cutter and cut the straight key there as well. All right, so to tighten it up, what I like to do is, for video purposes here, I'll flip it around to this side so you can see it, and just stick it out, and then I'm going to use a pin spanner right here. This is what I've got to do this with. And I'm going to tighten it up. That should be good and tight for what we're doing. I'm going to flip it back around. We'll just put it there about flush with the end of the vise. Tighten the vise up. We're going to take our dead blow. We want to bump it down until the parallels are snug. Right there it's got tension on the parallel, so we'll just leave it right there. Now we just need to get centered up on our shaft. And what we'll do, we'll take the cutter, we're going to mount it in a 1/2 inch collet. We're going to come down to where it's touching the top of the shaft. I'm going to use a piece of paper to set the touch off on the top of the shaft right there. We'll get it set up and I'll show you what I mean. All right, we've got her mounted in our 1/2 inch collet nice and tight. I've just visually centered it up on this journal right there. I'm just looking down. The cutter is about the same width as the journal there, so it's not going to hurt it one way or the other if you're to the left or the right a few thousandths on being in center. All right, so now that we're centered that way, I'm going to go ahead and lock the table in X, make sure it doesn't move. Go ahead and hit a 0 there. So what we can do is take our cutter. I'm just going to very gently come down and touch the shaft, and I'm going to lock the spindle right there. Now I'm going to come over to my knee and I'm going to drop it down. I just dropped it down and then brought it back up to 10 thousandths before 0. I've got a standard piece of printer paper right here. I'll mic that. It's 3 thousandths thick and it should fit directly underneath this cutter just like that, see? Then what we want to do is I am going to slide that underneath there. Hold it very gently with your fingertips, and it would help if you put it in gear. So let me do that first. Hold it. All right, see the cutter there? Still spinning, it's not grabbing the paper. I just want to come up, I'm bringing the knee up very gently. Now I can feel the cutter trying to grab the paper there. Hold it very gently with your fingers, and it just pulls it right on out, just like that. And what that's doing on our knee, that's showing me that I've got 5 thousandths from where I touched it off and brought it down. So that's going to put you extremely close right there, then you can adjust your offset there on the knee. So let's go ahead and bring it out of the way. I'm going to adjust it up 3 thousandths. And it's just starting to rub that shaft right there. So we are right where we need to be. So now we need to raise the knee up so that our shaft is going to be in the center of our cutter. Now that we're touched off on the edge there, we know where we're at. So real simple, all you do is just take half the width of the cutter, half the diameter of the shaft, which is these two values right there, add them together, and that's going to be our offset there for our knee elevation. So we've got her set to 0 over here, and we're going to bring it up 359.5 thousandths, okay? So I'm going to watch this, make sure that we're clearing our spindle. So 1, 2, 3, 30, 40, 50, and then we want 9.5, 359.5, and it looks like we're going to clear. We're definitely going to clear over here. We're not going to hit anything on that side. All right, so we should be in the center of our shaft now. All right, I'm going to see if I can get our flat established so we can set our depth. I'm going to put my little mag base light right here so that I can get a little extra light up in there and see this. Wrong way. What I'm going to try to do is get the full width of the cutter. Looks like we are just about there. I know that's hard for you to see, but I'm just trying to get in there and zero out my Y. 0. And I think that's going to be good right there. Yep. All right. So we've gone past it a couple of thousandths. That's okay. So we've got our width there. So I'm going to come back in. And I'm going to back it off about 5 thousandths. Right about there. And that's where I'm going to start my cut. So I'll get you zoomed in a little tighter so you guys can see this cut as it's happening. I've got the mill set at 325 RPM. That's going to put us right around 53 surface feet per minute. to 167 depth. Should be it right there. Got a nice looking key seat there. Okay, we've got that one done. I'm gonna just move this on down. What I'm gonna do, I wanna come in and I wanna just touch the face of that shaft. I'm gonna do the same thing. Let me find my piece of paper. What I wanna do is make my offset for the x-axis on our other keyway. So I'm just gonna hold this here with my fingers very gently. I'm gonna run this cutter in, and when it touches that paper, it should just pull it right on out of my fingertips there. I'll make sure that we are on the face of the shaft. Getting close, I can hear it trying to cut it. There it goes, just ever so gently. A lot of people are probably going to look at this and think how dangerous that is. I'm telling you, that is the old school way of doing things, back before the CNCs took over. Heck, I bet you a lot of you guys are still doing that on CNCs as well. I don't know. We'll find out though. So anyway, we got the cutter. I know the diameter of the cutter here. So all I want to do is just offset my x-axis to our 0 location there. We're going to climb cut this key whenever we do this. So we're going to be offsetting it 812 thousandths. It's 13/16. There we go, 812. Up here on the DRO, I'm going to hit a 0. And that is going to be our stop point right there, which should be about center of where the threads end. We want a 1/2 inch of a good keyway without the radius in there. So we've got that 0. Let's go ahead and we're going to go ahead and get this one done next. Basically doing the same thing I did before, but now since I can move it down, I can just run it to get my flat. Reach behind it here. I'm not quite flat yet. I'm just going to do this until we get a flat established, and I think we're just about there. Let's go in a couple more. All right, there we go. So there's our flat. Now I'm going to go ahead and offset it 50 thousandths because that's our depth of the key. And that's not really a critical depth either, but we're just going to take it to 50 right there. Now we are ready to cut our keyway. We use our power feed. Put a little tension on the lock. Watching the DRO till we get to our 0. There we go. So we'll do a little inspection to see if I hit my depth there where I want it. We got our Woodruff key here. I was going to show you this first. This is our little retainer that's going to slide up on there, and that's all that key's for, is there to keep this from spinning, and which this ends up keeping the bearing nuts from spinning. All right, we've got our Woodruff key. it's fitting in there. All right, so what I'm gonna do, I'm gonna take our 1-inch mic, I'm gonna mic over it, try to get it nice and centered there, mic it right in the center. .635, 678. All right, so we are at .638. And then we're going to subtract our diameter of our shaft, so minus .563 equals 75 thousandths. That's how much we're sticking out of the shaft there, 75 thousandths. So let's see what it said in the book we should be. 75 thousandths is where we're at. It says 78 thousandths is our key height, plus 5 minus 0. So I actually overshot that tolerance, and we are 6 thousandths deeper on the key than what we should be if we're making it to an industry standard. So 6 thousandths of an inch isn't going to make or break this job for us. We're going to roll with it, but I was just showing you, you know, how to check that, how to inspect it, and see where your depth at compared to your notes in the machinery's handbook. All right, so we're good to go. All we have left to do on this right here is to do some deburring there on the threads and the edge of the Woodruff key. All right, guys, our lead screw is finished. All the machining of it is completely finished. The only thing left to do is to start the reassembly, which we're going to wait until we're ready to put everything back together, because I don't want the bearings getting dirty. I don't want any dust getting up in them. But I'm real happy with the way this lead screw turned out. The threads, the Acme threads, I can't say enough about how well the Precision Matthews lathe did that right there. The threads, I can't show you on any kind of video how smooth and silky those threads are. That is probably some of the prettiest threads I have ever machined there without any kind of like polishing or anything on there. They just turned out so good. Just a beautiful thread. So I'm real happy with the way it came out. The PM lathe, it did an excellent job on that. So we've got here's our bearings that we went with, SKF 6201 bearings. The reason why I decided to go back with the same style that was in there is the way this is designed. You have a cap on the end with a screw. You remove that screw and you actually put oil down inside the bearing housing there. So you squirt oil in there regularly to oil these bearings. And that's why I went with that style there. We probably could have went with sealed bearings. It wouldn't have been able to have any way to oil it. Whether that's right or wrong with the best method, I decided to go the original style so that we can oil the bearings. It's going to be fine for the life of the machine while I have it. Maybe one day down the road, someone else is going to have this lathe, and they're going to be going in here and rebuilding all this just like I'm doing right here. The gears, both of them, I want to polish them real good and get them all cleaned up. They've got some burrs on here from people, you know, hammering and chiseling on it, and just get all those cleaned up. But once we're ready to assemble everything, that's when we're gonna get our bearings on there, press our gear, get our bearings on there, get the bearing housing, and start putting everything back together at that point. Our next piece in line is gonna be this guy right here. This is gonna be the lead screw nuts that we're gonna machine to match our new 3/4 5 left-hand threads. So this is coming up real soon. All right, the next piece of the puzzle right here. Once we get this guy machined, then we can begin our reassembly of all the component parts. All right, so that's it. Hopefully you'll be back for some more content, and we will see you hopefully on the next video.